Our topic is time complexity. Time complexity is a measure of how long an algorithm takes to run as a function of the input size. We typically want algorithms that have a low time complexity as they will be faster and more efficient. There are several different ways to measure time complexity, but the most common is by using Big O notation. Big O notation is a way of expressing the time complexity of an algorithm. It tells you how the runtime of an algorithm grows as the input size increases. Here are some common time complexities ordered from best to worst. The first one, the first time complexity, constant time. The runtime of the algorithm stays the same regardless of the input size. In our code, according to our code, we have a simple code. We have integer a and b. In our code happening 4 operations, but each row have only one operation and do their operation once. So this will be constant time complexity. The next one. So this one is linear time complexity. The runtime grows linearly with the size of the input. For example, iterating through a list once. We start by defining an array R with some integer values. When we then call the findMax method and pass the array R as an argument. This method will find and return the maximum element. We have findMax method. This method takes an array of integers as input and returns an integer. Initialize max element with the first element of the array and iterates through the array starting from the second element. For each element, it compares it with max element and updates max element if the current element is greater. Finally, it returns max element, which is the maximum element in the array. Print the maximum element. We finally print the maximum element found by the findMax method. So this is our linear time complexity. The runtime grows linearly with the size of the input. To demonstrate an algorithm with O and log n time complexity in Java, let's consider a simple example of sorting an array using merge sort. Merge sort has a time complexity of O and log n. In the worst case scenario, this is our example. Okay, we have output sorted array like 5, 6, 7, 11, 12, and 13. We'll have to find the middle point to divide the array into the halves. Recursively sort the first and second halves, merge the sorted halves. Okay. So we start by defining an integer array R that we want to sort using merge sort. The merge sort method recursively divides the array into halves until each subarray has only one element. It then merges the subarrays in a sorted order. The merge method merges two sorted subarrays into a single sorted array. It compares elements from the two subarrays and places them in the correct order in the original array R. Finally, we print the sorted array after performing the merge sort algorithm on it. Like this, our code, and this is our output. The next one is an example of an algorithm with quadratic time complexity. Like this. Okay. In Java is a bubble sort algorithm. Bubble sort compares adjacent elements and swaps them if they are in the wrong order. Here is the implementation. this code like this. Have some numbers in our array. Okay. We defined array. We start by defining an integer array R that we want to sort using the bubble sort algorithm. The bubble sort algorithm method implements the bubble sort algorithm. It iterates through the array multiple times, comparing adjacent elements and swapping them if they are in the wrong order. With each pass through the array ensures that the largest unsorted element bubbles up to its correct position. We printed the sorted array. Finally, we printed the sorted array. After performing the bubble sort algorithm on it, the output shows the elements of in ascending order, like this. This is our final result. Bubble sort has a time complexity of quadratic time complexity because in the worst case scenario it requires n iteration for each of the n elements, resulting in n multiple n comparisons and swaps. Okay, the next example of an algorithm with cubic time complexity n power of 3. In Java is the following code that performs a simple operation on all possible triplets of elements in an array. The first one, we start by defining an integer array R. The process triplet method implements a cubic time complexity operation by iterating over all possible triplets of elements in the array R and printing them. This involves 3 nested loops, each iterating over the array R. As a result, the total number of iterations is n multiplied by n multiplied by n, 3 times n, where n is the number of elements in the array. For the input array 1, 2, 3, 4, 5, the process triplets method will output all possible triplets of elements such as 1, 1, 1, 1, 1, 2, 1, 1, 3, and like this. This is our output. This example demonstrates an algorithm with cubic time complexity because the number of operations grows cubically with the input size n.